This tutorial, I'm going to quickly go over exam number 4. This is the last exam of MP1. I'm not sure if you notice, I gave you multiple set, but I made it almost impossible to notice. In the future, please make sure you know that the people sitting next to you taking different tests, so please don't copy. Problem number 1, I gave you 13 problem. Problem number 1, I took it from the Regions 2019, question number 40. Let's go over problem number 1. So I gave you 4 scenarios: scenario 1, 2, 3, 4, right? dyt, 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 right? So what height is saying? So what you did, you throw a projectile. You kick a soccer ball. You kick a soccer ball, right? But not with the same angle. This angle is, let's say, I don't know, 45 degree, 30 degree, 45 degree, 60 degree, but not with the same velocity. This, let's say you did it 10 meter per second, 10 meter per second, 20 meter per second, and 20 meter per second. So you know that the range, this is what you try to find. Which one has the maximum range? Is this one, or this one, or this one, or this one? Okay, so I don't know. Which one is bigger? I don't know. Okay, let's find out the size. What is the size of this one? The size of this one is dx is equal to vxt. Same thing, dx is equal to vxt, dx is equal to vxt, dx is equal to vxt. Now, you know that this has a two component. Velocity has a two component, vx, dy. The range depends on vx. All right, so vx is 10 cosine 45, and that is 7. So dx is 70. 10 cosine 30, this is 9, or 8.7. So dx is 90. 20 cosine 45, which is 14.14. I'm going to just write 14t. 20 cosine 60, which is, I don't know, 20 cosine 60, which is 10, I believe, I don't know, 10t. But one thing you know that the t is same way, because height is same. If height is same, t is same. So let's say t is 1. So dx is 7, dx is 9 meter, dx is 14 meters, and dx is 10 meters. Keeping the t same. 1 second. Even if I make the t 2 seconds, the answer would still be the same, and that is, this is the biggest. All right. So was my assumption right? Is this one bigger than this? Yeah. Is this one bigger than this? Yeah. Is this one bigger than this? Yeah. So this is the biggest. So answer to question number 1 is 3. Now let's go over problem number 2. It's pretty easy. You did it many times in the classroom. So if you have a building which is 65 meter tall, right? A 65 meter tall building, 65 meter tall building. What you did, it's like a marble roll off this table, right? The table that I'm using here in this classroom, 2E6. Now, if you throw something with, I don't know, it doesn't really matter how much uh, velocity marble accumulate over the time. If it rolls off the table and at the edge the marble falls with that horizontal velocity, it has nothing to do with the vertical velocity, because particle velocity is 0 and it will not affect the time. What does that mean? That means with the horizontal velocity, it doesn't matter how much it is. And the vertical velocity is always 0 when something roll off the cliff. Now, it falls, right? It falls like this. When it falls, like, let's say how much? It falls, it falls 25 meter, right? 25 meter, all right? From here to here is 65. I cannot erase it. From here to here is 65 meter, right? If it falls only 25 meter, well, and it falls with the horizontal velocity, I don't know, 35 meter per second, right? In fact, the horizontal velocity would be the same from beginning to end. Here, horizontal velocity is 35 meter per second. Here is the same. Here is the same. Here is the same. Horizontal velocity does not change because acceleration due to gravity at the x direction is zero. And we said many times that um, uh, the vertical velocity would changes. Vertical velocity is zero over here. Vertical velocity would increases, right? The vertical velocity would increases, but horizontal velocity remain the same, and that's the story. The set B, I changed the horizontal velocity. I changed it to something else for set B. Folks who are taking set B, 45. So this was 45 for set B. This is 45. If it if it drops with 45 meter per second, then this is 45, this is 45, this is 45, this is 45. What does that mean? The horizontal component of the velocity is not a function of time. Nothing to do with the time. It's a constant. In fact, if you draw the horizontal velocity, it's going to look same. It's constant. It doesn't depend on the time. And that's what you see here on the graph. And that takes us problem number 3. Problem number 3 is very easy, right? All you need to do from this is start. And I'm going to draw the vector. This is the displacement vector. Displacement is by definition the shortest distance between 2 points. So the shortest distance between 2 points is not this. Shortest distance between 2 points is not this. The shortest distance between these two points is this one. So what is the size of this one? We already know that the direction is south. Okay. So what is the size? The size is the this plus this. So 8.8 0.8 plus 0.6, 1.4. So 1.4 kilometer to the south. So 1.4 for kilometer to the south. And that takes us problem number 4. What is problem number 4? Problem number 4, I give you different things to different people. This one is 100 meter per second. If your velocity, initial velocity is 100 meter per second, what is the both component of the velocity? So 100 cosine 15 degree and 100 sine 15 degree, right? 100 cosine 15 degree is 96.6 meter per second, and 100 sine 15 degree is 26 or 25.9 meter per second. Set B, instead of 100, I wrote 10. So the answer would be same. Why is that? Because Vx, Vy. What is Vx? 10 cosine 15. And this one would be 10 sine 15. So 2.6. For other people, set B, this is the answer. But set A, answer is this one. Problem number 5, what happened? A building which is 6 meter tall, right? A ball rolls off of this building and accumulates some velocity, which is 15 meter per second in the x direction. And when it's rolled off of the cliff, y direction, y component velocity is always 0. And if this ball lands over here, right, what would be the time from the ball is in the air? So 6 minus 3.6, 6 minus 3.6 is going to give you 2.4. Now you're going to have to find that. So 2.4 meters. So D is equal to VAT plus half AT squared. What is your goal? Your goal is to find how long the ball is in the air. This is 0. Why is that? Because this one is 0. When it's rolled off of the cliff, y component of the velocity is 0. I said it many times. Many times. What is dy? Dy is negative 2.4. Right? This is negative 5 t squared. So negative negative cancel. T squared is equal to 2.4 over 5, and t is the square root of 2.4 over 5, and that gives you 0.70 second. So t is 0.70 second, and that is option number 3. Now let's go over problem number 6. Above more 40 meter north, right? Okay, the direction is north and the size is 40 meter, and And then it moves 40 meter east, and it moves 40 meter east. Now remember, uh, this is this is measured in meter, this is measured in meter, so we should be able to use Pythagorean theorem. In fact, we use e square plus 40 square, and that's going to give us how much? That's going to give us 57 northeast. So this is going to give us 57 northeast. You throw a ball, this is dyt, you throw a ball upward, right? So what is the velocity over here? The velocity over here is 0, right? However, acceleration over here is not 0. In fact, acceleration over here is negative 10 meter per second squared. To be more precise, negative 9.8 meter per second. Acceleration due to gravity is never 0. Never. Never. Okay? So, uh, the velocity, they are not being, okay, so that I will stop it over here. Number 7, um, the reasons physics should have been more careful writing this type of problem, because this Vy is 0, right? Vx is never 0. Even over here, right? Vx is never 0. So the question should have been uh, velocity at the y direction is 0 and acceleration is non-zero. That's velocity at the y direction is 0, or vertical velocity is 0, and the acceleration is non-zero. That's how it should have been. But since uh, they are trying to generalize it, you have to be careful and make sure that you know what they want you to know, and that is when they say velocity is 0, they mean velocity at the y component is 0. Okay, when you say z is equal to negative 10, what do you mean is g at the y direction is negative 10. Obviously, they're not going to write y because they expect you to know these kind of things. Obviously, this question was taken from the question number what? Question number 7. Question number 7 was taken from Reasons Physics 2019, problem number 3. So make sure you kind of know what they expect you to know, so you won't make mistake when you take the reasons in 2025, June 2025. Let's move to problem number 8. Catapult or kicking a soccer ball is the same thing. So let's say you are here, right? Again, this is, let's call it dt. Let's call it dyt, and you know you are the target is here, right? Even the soccer ball, right? You are here, target is here. Target means the another goal post, right? Goal post to goal post. You send this to the other goal post, and how long the ball? Okay, location 1, you can say this is location 1, this is location 2, this is location 3, this is location 4, and this is location 5. We often say that to make to divide and conquer, to understand it better. At location 5, what is the time? The time at location 5, say this is location 1, 2, 3, 4, and 5. So this is time, and this is velocity, right? At the x direction, this is velocity at the y direction, and this is velocity in general. Okay, we did it in the classroom. And this question was taken from, I'll tell you right now what year. This question was 2019. This is 2019, problem number what? Problem number, question number 40. 2019, question number 40. Okay, all right, the time. They gave you the time, how long the ball was in the air. How long the ball was in the air? I believe 0.8 second. So the ball was in the air 0.8 second. That means at location 3 is 0.4 second. Vy at location 3 is 0. At location 5, okay, this is the information we know. We also know the displacement and max height. So let's write dx and dy, dy maybe, yeah, sure. dx at location this one, this is we are trying to find out no we don't, this is probably given, this is 2 meter, this is 2 meter is given, and the maximum height at location 3 is the maximum height, and maximum height is how much, is 0.78. All right, so this is the problem. Now you want to find the here's what we want to do. We want to find the velocity initial is equal to vx squared plus vy squared. V initial x squared, v initial y squared. Let's find vx. Vx. How can we find the vx? To find the vx, we know that dx is equal to vxt. So what is vx? Vx is what is dx? Dx is 2 at location 5. At location 5, dx is 2. So you're going to put 2. Vx you're trying to find. At location 5, time is 0.8. 0.8. So Vx is 2 divided by 0.8, and that is 2.5. Okay, we know one component, and that is Vi is equal to 2.5 squared. Yeah, 2.5 squared. Now, Vy, how can we find the Vy? Well, that's easy. To find the Vy is equal to Vf, let's say Vf is equal to Vi plus At. Now, we're going to put 0 over here. If we put 0 over here, we cannot put 0.8 over here. Why is that? Because velocity is 0 over here, right? And the time is definitely not 0.8. Time is 0.8 over here. So the time is then 0.4 over here. So we're going to put 0.4 instead of 0.8, 0.4. And Vy, guys, the Vf is 0. Vi is, we are trying to find Vi, of course, y, minus 10. So Viy is equal to 4. So you're going to write 4 squared. If you do that, then you're going to see 4.7. And then, so this is 4.7 meters per second, of course. Number 9. Number 9, let's see. So you know the road is like that, and there is a car, right? The car moves with some velocity, and velocity is how much? 16 meters per second, right? However, there is an acceleration opposite direction. How much is that? 2.2 meters per second squared. For how long? The car was accelerating against the velocity 5 seconds. What do you try to find? You try to find how far does the car move. Meanwhile, d is equal to vat plus half at squared. So this is one of the easiest problem. Vi is okay, 16 times 5, and then minus, why minus? Because acceleration is negative, 1 over 2, 2.2, and then 5 squared is 25. So this is going to give you 80 minus 1.1 times 1.1 times 25, so 27.5. So 80 minus 27.5, so 52.5 meter. And how far does the car move during this 5 second? 52.5 meter per second. This one is the easiest problem in the test, and that is problem number 10. Why is that? Because hey, point number 1 problem in the test. So point number 1 is 0 comma negative 10, and point number 2 is 5 comma 40. 5 comma 40, 0 comma 0 comma negative 10, and 5 comma 40. So this is x1, this is y1, this is x2, this is y2. Slope is y2 minus y1, x2 minus x1. Y2 is 40 minus y1 is 10, x2 is 5 minus 0. So 50 over 5, that's the slope. So slope is 10. This is velocity versus time. So what is the name of the slope? The name of the slope is acceleration. So this is 10 meters per second squared. And that's what it is. Okay, and then take us to the problem number 11. A ball roll. This same problem I give you many times. Remember what I said, like Mr. Bari, run on the rooftop and run off the rooftop with some horizontal velocity, and horizontal velocity has nothing to do with how long it does take for him to land the ground. Okay, all right, so similar problem. Okay, so here what is going on? The velocity is Vx and Vy. What is Vx? Doesn't really matter. Vx is the ball traveling at 2.5 meters per second when it reaches the edge of the table. All right, so 2.5 meter per second, right? Vy is 0. Okay, and the ball is strike the floor. Uh, 2.91 second after it's okay. So the ball land on the ground, and the ball was in the ground. Ball was in the air for about zero point 0.4 second. We want to know the height of the table. Okay, so d is equal to vat plus half at squared. Of course, y is 0 over here, so we're going to let it be 0. And height is -5, and t is, don't forget, 0.391 squared. So 0.391 squared, 0.391 squared times 5, that gives you 0.76. So this is minus 0.76, but you take the absolute value because they want to find they want you to find height. So height is 0.76 meters. So the other ball falls with double velocity. Okay, the other ball falls with velocity is instead of Vx being 2.5, Vx being 5 meter per second. Vy is still 0. Now, in this time, which one will take longer to hit the ground, right? Because this one is falling half the velocity with the B, okay? So, or the B is twice as much as the A in terms of velocity at the X direction. But did I not tell you many times that velocity at the X direction do not contribute the time? It doesn't. If you fall from the same height, velocity at the X direction doesn't matter. Only velocity at the Y direction contributes to the time. So it's going to take the same time. In fact, you can try that. You can test that. It takes the same time because this is the same height. What is the height? 0.76. So it's going to take the same time. How much time? 0.391 is going to take how? So you can check that d is equal to VAT plus half AT squared, right? And this is 0. So d is equal to, d is 0.76 is equal to, what is it? Negative 5 t squared. Okay, this is negative 0.76. Negative negative cancel. So 0.76 divided by 5, and that gets 0.152 is square root of 0.152 gives you the square root of 0.152 gives you 0.38, 0.38. And that's the same thing. It takes the same time. Okay, good, because I compromised the decimal. Now the last question, you drop it from 80. Then the other set I gave you 45, but this one I gave you 80. If you drop it from 80 meter tall, then it takes only 4 seconds. How is that? D is equal to VAT plus half AT squared. Since you want to find the time only y direction, the Vy is 0 when you drop. Okay, and how long? Negative 80, negative 5 t squared. So negative negative cancel. 16 is equal to t squared, so t is equal to 4. Once you know the time, everything is easy. So this is 4, and this is how long? Of course 80. So you know this. This is how long? 4, and this is how long? 40. How it is 40? Because Vf is equal to Vi plus At. How long does it speed? It is speed only 4 seconds, because you already found the 4. Negative 10 times 4, which is negative 40. Of course, you take the absolute value, so it's 40. So 40, but never forget to shade area under the curve, otherwise I'm not going to give you the point. The displacement for second, of course, is negative 80. So it's a half of the parabola, because the other half is missing, is because the time cannot be negative. Okay, good. And then this one is, of course, for same reason, df is equal to vi plus at, and this is 0, and this is negative 10 and times 4, so negative 40. So this is negative 40, and this is 4. And don't forget shade area under the curve. And this would be what? This would be half, base is 4, and height is negative 40. So this is negative 80, and this is so this is negative 80, and this is positive 80. Let's prove that. Okay, the other set B, instead of 80 I give you 45. So then if this one is 45, you change nothing, you just write 3 second and 45. You write 3 second and then 30. You write 3 second and then negative 30, negative 45, and you write 3 second and negative 30. Okay, all right, so yeah, that's it, because this is then negative 45 and this is then positive 45. All right, okay, so yeah, that was exam number 4. See you Monday. 19, question number 40. This is 2022. Question number 4. This is again 2022. Question number 15. This is 2022. Question number 37. Question number 48. This is 2019. Question number 2. This is 2019. Question number 3. This is 2022. Question number 67. Number 37. This is 2016. Question number 56. This is 2016. Question number 57. So all the questions came from the reasons physics.